Greetings. In the last video, we worked out an independent t-test problem by hand, and we came to the conclusion that we wanted to reject the null hypothesis, and we did it through kind of maybe not the clearest logic process, but it is the prevailing way of doing this test, where you're looking at whether or not your calculated t an absolute value is greater than this critical t. And remember, what you're saying here is, I'll go back up to this one right here, you're saying that you've calculated a t value that was over here on this side of this cutoff, and this cutoff was 2.201 at this degrees of freedom, and you're saying because our calculated t value was beyond this cutoff zone, that we're willing to challenge that null hypothesis. Another way of doing this that might be more intuitive, that kind of ties us back into the null hypothesis, is an extension of a concept that you're already aware of, that we've covered in this course, which is the confidence interval. And so you can make a confidence interval around this numerator piece right here, kind of this mean difference. So the general form for this looks like this: a 95% confidence interval. Again, 95 is just by convention. You can make a 96, a 97, 98, but a 95 is certainly the most popular convention for a confidence interval. But it takes the general form: the mean of group A minus the mean of group B. You're going to get a mean difference score here, and then you're going to add and subtract from it to get an interval, the cross product of that critical t, which was at your chosen alpha, two-tailed, and at a particular new value, multiplied by that standard error of the differences between mean A and mean B. So that is your generic form here. So let's plug and chug this for us. What does that mean? So 95% CI. Well, what was the mean or the difference between mean A and mean B? Let me do this in red. It was this value right here, right? The negative 0.99. And then to that, we're going to add and subtract what? Our critical t. Here was the critical t, 2.201, multiplied by this standard error of the differences between the means. And where was that? That is this value right here. Going to rebox it again, which was 0.40. So when you do this, and you basically multiply these two out, add it to 0.99, and then take this value, this cross product value, and subtract it from negative 0.99, you'll get an interval that is negative 0.1096. That's the lower end of your interval, and your upper end of your interval is negative 1.8704. Let me make those brackets bigger. Okay, so this is the upper end. So what does this mean? How do you interpret it? Well, this is why I think this makes more sense relative, confidence intervals make more sense relative to the null hypothesis. We can go back up here just again and go back to blue just for a moment here. But if you remember, the null hypothesis says that the mean of group 1 minus the mean of group 2 equals 0. And that's what you've done right here. You're basically saying, I want to test whether or not 0 is a possibility, right? If 0 is a possibility, so if I'm to the kind of like to the left of this line, I'm saying 0 is a possibility. If I'm to the right of this line, I'm saying, well, 0 is not a possibility anymore. And what does my interval contain? So if my interval contains, if interval contains 0, what would the outcome be? The outcome would be I would fail to reject, i.e. not challenge the null. Right? Not challenge the null. Let me switch to green. However, if interval does not contain 0, I'm going to reject the null, i.e. I'm going to challenge the null hypothesis. And look here, I mean, I'm going from a pretty high negative number here, and I'm approaching 0, right? But I never went to the other side of 0. And so 0 is not in this interval. And so therefore, what am I doing? I am going to challenge the fact that 0 could be an outcome, just like the null hypothesis said, that 0 could be the outcome. I'm going to challenge that, and I'm going to reject the null. So confidence interval is just another way of getting at the same information. And so you may come across this. The traditional way that you'll see in journal articles is kind of the one that we did when we worked out the problem in terms of calculated t beating critical t. And then they'll report what their calculated t-value was, is kind of the syntax that you'll see in the article. But a more contemporary way of dealing with this is really to use the confidence interval. So I just wanted to introduce it to you as a concept and extend it from just a regular confidence interval that you learned before around just a sample mean. And so that's it for this particular video. Thanks for watching.